The next type of thing that we're going to measure is a variation. Okay, and so when we've got numerical data, when we've got quantitative data, we'd like to know how spread out it is. Okay, so for example, some things are really spread out and others are not. For example, if I look at a classroom full of students, then the heights of those students is probably not super spread out. However, if I were to look at perhaps income, family income of students, then it may be extremely spread out. And so we would like to come up with ways to measure how spread out a collection of data is. The first measure of variation is range. This is really easy to calculate. The range is just the difference between the maximum value and the minimum value of the data set. So you've got a set of numbers, you just take the biggest number minus the smallest. Okay, and that's going to be the range. Biggest minus smallest. And that's going to be your range. Now, range, even though it's so easy to calculate, is actually not an extremely useful number. For example, if I, say I was looking at height of a group of people, and say that the range was 2 feet. Well, that's quite a big range. So that tells me, that the tallest person and the shortest person in the group are their height difference in height is 2 feet. That's a big difference. Okay, but that doesn't tell me if maybe there's just one NBA player in this group of people, and everyone else is just a normal height, or maybe it really is very spread out, and about lots of really tall people, lots of short people. We don't know, and so the range is easy to calculate, but not particularly useful as far as knowing about all the data in the set. What we're going to use instead usually is standard deviation. Okay, this is a way of measuring how much in our individual data values deviate from the mean. Okay, so there's some things to know about this. This is just some facts to know. First of all, it's always going to be a positive number, and it's only 0 if every single data value is the same number. And then as we spread our numbers out, the standard deviation gets bigger. The units on standard deviation is the same as the units on the original data. And it can be highly influenced by outliers. Okay, so if I have a group of people and I ask their income, if there's one person that's making millions of dollars, but everyone else is just a standard middle class, that's going to affect my standard deviation. Okay, let's look at the process that we follow. This is how we find standard deviation. So the first thing we do is we find the deviation of each data from the mean. That just means we subtract the mean from the data value. So take the data value, the value, minus the mean. That gives us our deviation. Okay. Then we're going to square the deviation. So you just take the number and multiply by itself. That's going to turn it into a positive number. Okay. We then add all of those together and divide by n minus 1. This is where n, okay, is the number of data values. Number of data values. Okay. Once we've done that, we're then going to take the square root of the result. Okay, this is kind of to balance out the fact that we squared our deviations. We don't like that we actually did that. We would like to kind of get rid of that. So we're going to do the square root. Now, it doesn't actually get rid of the squares, but in some way it does balance that. Let's do it then. Let's find out what the standard deviation of these data here are. So we have to start by finding the mean, because we need to know the deviation of each value from the mean. So to get our mean, we are going to add our numbers together. 4 plus 5 plus 16 plus 12 plus 3 and divide by the number of values, which is 5. And we get 8. Okay, now we're going to calculate our deviations. Deviation, and we're going to do it for each number. So to do that, we're going to we take our number and minus the mean. So for 4, we do 4 minus 8, which is negative. And we do it for 5. 5 minus 8, which is negative 3. And then 16 minus 8, which is 8. And 12 minus 8, which is 4. And 3 minus 8, which is negative 5. Okay, and then we square each deviation. All right, so we do each of those squared. So let me do action in a separate column, square. So negative 4 squared is 16, and negative 3 squared is 9. Okay, so we get our square deviations, and then we add those all together. All right. So we add these together, 16 plus 9 plus 64 plus 16 plus 25. We get 130. Okay, then we divide by n minus 1. Okay, so we take 130, we divide by, n is how many things there are, which is 5. So we're going to divide by 4. Okay, you divide by 1 less than how many there were. So 130 divided by 4, which is 32.5. Okay, and then we take the square root of the answer. So the standard deviation is equal to the square root of that number, square root of 32.5, which is about 5.7. Now what this number is a measure. It's kind of like an average distance of these numbers from the mean. Okay, kind of. It's not exactly, but the average of 4, 5, 16, 12, 3. We find how far away are those from 8, and that's these numbers here. The reason we square them is because we don't want to add these and have positive and negatives cancel each other out. Okay, so we square them, add and divide by n minus 1. The reason we divide by n minus 1 is actually is pretty involved, but it actually comes down to the fact that we're estimating. Generally, our data set is for a sample rather than a population, and which means that we're actually estimating, and dividing by n minus 1 instead of n actually helps us so that our standard deviation is a better approximation to what the population standard deviation would be.